Welcome to the conference, The Future of Liquid Fuels for Heating. My name is Moritz Belling. I'm the chairman of Eurofuel, and I will guide you through today's event. This is the second conference day in this year. After the successful last year's event, I'm very glad that we, together with our colleagues of NORA, can present such a meeting again. Last Thursday, we focused on political issues and heard a lot about future developments in Europe and in the United States. Despite different approaches, the common goal is clear. The climate-relevant emissions are to be reduced to zero by 2050. The goal is ambitious, and the measures to achieve them are very comprehensive. Today, we will focus on technical aspects. We will have presentations from fuel providers and suppliers. We will have discussions with boiler and equipment manufacturers, and we will get first-hand information from specialists dealing with renewable fuels. I very much hope that we put together an interesting program for you in which various possibilities are shown to solve the trouble with the high environmental goals and that we can achieve them. But let me start with some antitrust notices. For antitrust competition law reasons, the following points must be observed, generally not permitted. To discuss prices, conditions, quantities and sales areas, the exchange and/or discussion of unpublished plans or projects of companies such as investments, introduction of new products or services, purchase prices and conditions. The video conference will be recorded. The chat history will be saved for internal purpose to enable post-processings, and after the conference, you will find the recording of the presentations on the Eurofuel and NORA websites. But now I would like to take over to John for his welcome from NORA side.
Thank you, Moritz, and you've covered a lot of ground. As we did last week, I think in assessing the political situation we have as an industry, we had a number of speakers talking through Europe and the United States, and particularly the states within the United States, as to the types of solutions they were looking at for global warming. At this point, we unfortunately have seen very little interest in a green fuel, even though we in this industry think that the green fuel has the best potential to reduce greenhouse gases quickly and efficiently. So that is our political lay of the land. We have to do something, and we have to do something very quickly. Today, as Moritz indicated, we will be looking at the technology side. And I think something we all have to think about is we need to accelerate the development of technology and the development of knowledge. And that's why I think this conference is so important, that we have both our team at NORA and other researchers in the United States working hand in hand and hearing about what's going on the other continent. We have no time to duplicate research. We need to build on each other's successes and what we're doing. So with that, I think it's so important that we're doing this, and having the top researchers and technology experts in our industry talking to us each day. So I want to thank all the participants today. I want to thank Moritz for hosting this with me, and Eurofuel doing such a good job of getting excellent speakers for today. And we really look forward to hearing how technology is developing in Europe and the thinking behind biofuels. So thank you all, and I will talk to you at the end of the session.
Now we would like to start with the first session regarding renewable liquid heating fuels in the marketplace. And the first speaker is Arto Hanula. Arto is a member of the Eurofuel board and the executive director of LEI, which is the Finnish Heating Energy Association. Finland is one of the leaders in the production and use of renewable energies. ARTO will focus on the production and use of hydrotreated liquid fuels. ARTO, the floor is yours.
Thank you, Moritz. It's nice to be here, and I'm going to briefly tell you about this Finnish heating market. What is the situation on the moment in Finland? So first slide, please. A little bit about background. We have on the moment approximately 130,000 detached houses with oil heating. On the beginning of 2000, there was 250,000 houses with the oil heating. So it has been dropped down about this more than 100,000 houses. But on the other hand, there's 90,000 boilers which have been renovated in 2000. So those 90,000 is already suitable for the renewable heating oil. Very most popular heating is this electric heating. There's approximately 600,000 houses. Approximately 70,000 houses are with the district heating, and we have to remember that in district heating, 50% of production is produced with the fossil fuel, so it's not renewable heating yet. And this more and more popular has become to this using these heat pumps. So there's about 140,000 ground source or air water heat pumps. So next slide, please. On those figures which I just told you, we evaluate that approximately 40,000 houses are some kind of hybrid systems. And this renewable heating oil is available since on the beginning of this year, so 2021. And there is distribution obligation, which means about 3% of the energy content of the fuel must be renewable, and it will rise up to 10% on 2028. We made field tests in Finland approximately 10 years ago, so 2008, 2010. And in those tests, we had 30 houses, whereas 15 tested with the FAME and 15 with the HVO. And now, which we have on the market is this 100% HVO. So there's no blend on the moment. But in those tests, what we had in that time, it was a different kind of blends and also the 100% HVO, which we tested. And it works quite well in all the cases. Next slide, please. When we thinking about this use of the renewable, so we recommend to you make some maintenance before to start using the renewable. First thing is that we recommend it to clean the tank, because old tanks, it's always some particles on the bottom and so on, and it may get moving on those to the filters and cause the problems. So we don't want that this, if they start using the renewable, it's not the point that you get the problems because you have a bad tank. Another thing is to make some kind of service or maintenance for the burner and check that it's suitable for the renewable oil. And One main point is that this renewable burns a little bit pride of flame, so you have to check the flame detector so that it works well with this 100% HVO. If it's blended, so it's not the problem, but when you have a 100% HVO, it's need to be checked that it's okay. Then we how we do this training for maintenance companies is that we will have that kind of training days. But first thing what we have been done is that technical recommendations which has been sent it to all the companies so that they have some kind of knowledge already what they shall do in the future. Next slide, please. There is a picture which shows that why we are recommending to use this in the beginning with the hybrid systems. In the hybrid systems, it's very popular in Finland at the moment to use this air-to-water heat pumps, and then together with the oil boiler. And average energy demand on those houses in Finland is 22,000 kilowatt hours per year. That's average evaluation. And if we produce 70% of this energy demand with this heat pump and 30% backup power from this oil boiler or electric boiler, this figure shows that what is the difference. When we're talking about the emissions, it means that emission in the cold days, because the air-to-water heat pumps can be used up, down, or up, however you would like to say that. It's minus 15 degrees. Its output is about half of its nominal output. And that means that you need some kind of backup power. And normally you can use the electric, or then you can use the oil boiler. And if you use the electric in those cold days, which is under the minus 15 degrees Celsius, it means that you have a more emission, CO2 emission. And in those cold days, electric emissions is about 150 grams per kilowatt hours. That means that this kind of combination, just using the electric and the air-to-water heat pump, produce approximately 1,500 kilograms is CO2 emission. If we calculate the average emission from electricity, which is around 91 gram per kilowatt hour, it means still that there's 1,000 kilograms. But if we use renewable oil as a backup, it's only 500 that CO2 emission. So it's a very good solution to drop down the emission. Of course, if we are using just pure, instead of fossil oil, we change the oil to the renewable, we can drop this emission immediately. But it might cost a little bit more about this fuel. But in the emission, it's better to using this kind of combination: oil boiler with the renewable and air-to-water heat pumps, for example. Thank you.
Thank you, Arto. That was an interesting insight in the activities, and I think hybrid is, I think, one of the solutions who may help. I just have a look if there are some questions in the chat. By the way, you can ask your questions in the chat. I will have a look if there are some, but I don't see. No. So then we switch. Thanks, Arto, for this interesting insight. Then we switch over to the next speaker, which is Matt Herman. Matt is the director of the National Biodiesel Board and an experienced sustainability professional with deep experience in life cycle assessment. In his presentation, he will focus on biodiesel issues. Matt, the floor is yours.
My name is Matt Herman, and I am the Director of Environmental Science at the National Biodiesel Board. Today I'm going to walk you through a path to net zero soybean oil biodiesel. Today, soybean oil biodiesel can reduce emissions by up to 80%. While that is undeniably cleaner than petroleum and almost all other commercially available liquid biofuel solutions, 80% will not be enough in a world that demands net zero. Here we have a visual representation of the soybean oil biodiesel supply chain. Each stage, starting with farming, progressing through transportation, crushing, and biodiesel production are all accounted for. You can see that each stage of the supply chain I've assigned a carbon intensity. This number represents the grams of carbon dioxide per megajoule of biodiesel produced. As a point of reference, petroleum diesel has a carbon intensity of about 100. So if you add the feedstock portion plus the fuel production portion, you'll see that the direct emissions from producing soybean oil biodiesel are roughly 79 to 80% better than diesel. Now that we're familiar with the emissions profile at a high level, let's dig into the various stages to see what we can do to get to net zero. The vast majority of the emissions associated with U.S. soybean production can be categorized into two tranches: emissions from energy use and emissions from nitrogen. Focusing on the emissions from energy use, we can see that the biggest portion, the blue slice of the pie, is from diesel fuel used in tractors, sprayers, harvesters, and other combustion equipment. The model assumes that we use roughly 4.8 gallons of diesel fuel per acre, and that's based on USDA survey data. Additionally, there are small amounts of thermal energy and electricity likely associated with drying and irrigation. The use of biodiesel and renewable diesel could help significantly reduce these emissions, and the use of low carbon electricity could reduce the electricity emissions. Moving to the nitrogen emissions, which is the largest slice of the pie, you can see that they make up roughly 66% of the total emissions from growing soybeans. And these primarily come from the decomposition of biomass, not the application of chemical fertilizer. The Argonne model has broken these decomposition emissions down into two categories, one dealing with the decomposition of the traditional biomass, the gray slice on the right, and the second source, which is more uncertain, has to do with the decomposition of the plant nodules themselves. It's important to note that there's a high degree of uncertainty around these nitrogen emission figures, especially when you consider the role that soy plays as a nitrogen-fixing plant. For example, nowhere in the model does soy receive a credit for placing nitrogen in the soil for use by the following crop in the rotation. This is of key importance because the following crop is generally a cereal crop that requires the application of chemical nitrogen. This application of chemical nitrogen is reduced if soy is planted in the growing season before because of the residual nitrogen that's left in the soil from growing soy. So while better measurements will likely not zero out these emissions completely, we believe it will decrease them significantly, leaving the supply chain in a position to easily net out the remainder of the emissions through the implementation and use of things like biodiesel or other practices that could build soil organic carbon, such as reduced tillage, manure, and cover crops. Looking at oilseed transportation, we can see that the model assumes a couple of movements. Both of these are powered by diesel. One is using a medium-duty truck, and one is using a heavy-duty truck. It's easy to imagine that these emissions are associated with moving beans out of the field to a local elevator, or from a local elevator directly to the crush facility. The key takeaway here is that the emissions associated with these steps are diesel, and so decarbonization is going to require the use of biodiesel, renewable diesel, or a yet to be commercialized electric farm truck. Here we can take a step back and look at the whole picture for soybeans. You can see it isn't all that different than slide 4, but now with the inclusion of transportation, the share of the emissions associated with diesel increases, but it still makes up less than 20% of the total. While we have a lot of commercial solutions to reduce emissions associated with energy use, one of the key takeaways that I want to leave you with is that if consumers, governments, and companies want to demand a net zero supply chain, we're all going to need to work to develop a system that rewards farmers who already are or who would like to implement practices that enhance their soil's ability to store carbon. Now that we've covered the feedstock production stage, let's go to the fuel production stage, starting with the soybean crush facility. Crushing soybeans results into two products, soybean meal and a byproduct of soybean oil. Together, this process represents about 15% of the total emissions associated with the production of biodiesel. The data represented here is based on a rather dated survey of US soybean crushers and likely has some room for improvement. For starters, you can see that at the time this survey data was collected, a large share of the industry was still using coal to fire their plants. The trend in the US natural gas prices, coupled with ever-tightening air regulations, have likely led a lot of crushers to switch fuel sources. As the crushing community looks at their own carbon footprint, they will have two primary sources of GHGs to grapple with, those from thermal energy and those from electric. To the extent that a strong carbon incentive exists, you may see them seek new sources of thermal energy. This could come from the combustion of hulls, other biomass, potentially the use of biomethane, or even the combustion of waste products like their filter media. As many of these facilities are located in the Midwest, where wind and other sources of renewable electricity are gaining popularity, you may see them install on-site generation and or potentially electrify select aspects of their production that would have traditionally been driven by steam. Now, looking at the production of the biodiesel itself. The first thing you will notice is that during the last survey, someone reported diesel fuel used in their facility. Let's assume that that was a misinterpretation of the data, because splash blending diesel with the finished biodiesel at the facility should not be included in the carbon intensity of producing biodiesel. We also see that there's a small share associated with electricity and processed chemicals. Here, when we say processed chemicals, we mean in-process chemicals, for example, acids used to neutralize the process. It does not include chemicals used to clean in place, and it does not include catalyst. Catalyst is included in the methanol emissions. Similarly to crushers, biodiesel producers would be able to reduce their electricity emissions by incorporating renewable power. Innovative producers with plants in favorable locations like REG Albert Lea are already starting to incorporate renewable electricity. They recently commissioned a wind turbine at their facility. However, for those in less windy locations, an expansion of indirect accounting for the use of renewable electricity would be extremely meaningful in helping drive this change. Like crushing, biodiesel producers will also have to think about their option for reducing or changing their natural gas consumption. Certainly some aspects of their process could be electrified, but high temperature applications such as methanol rectification could prove more costly. This will be even a larger challenge for multi-feedstock plants which have to contend with the high temperatures required to pre-treat oil. Like nitrogen emissions for soybeans, methanol is going to be the most difficult component to decarbonize. There are a couple of options I see here going forward. One we are often asked about is the use of ethanol. While producers will tell you it's just not that simple to convert a biodiesel plant over to using ethanol. Biodiesel plants are currently designed to separate methanol and water, and the separation of ethanol and water is not as easily accomplished. Additionally, given the current carbon intensity assigned to corn ethanol, it's not clear that there would be significant emission reductions to the overall carbon intensity of biodiesel. Assuming producers stick to using methanol, that leaves them with a couple options. There is the potential to work with their methanol producer to see if they can procure biomethane, feeding it to the existing methanol synthesis process. This is something that we hear is happening in Europe today. Separately, producers could also consider the use of methanol derived from hydrogen produced from electrolysis and carbon monoxide. However, given the low penetration of renewable electricity and the cost of electricity, without expanding those indirect accounting provisions, it's probably likely in the distant future. Finally, the last option to consider is the conversion of biomass to methanol through a dedicated process. Today, there are a few folks playing in this space. Companies like Enercam are converting MSW to methanol. Additionally, there are biomass-based processes out there today that produce a waste methanol byproduct that's frequently burned for heat. This, in theory, given the right economics, could be separated and sold to biodiesel producers. Here we're covering the emissions of soy oil and biodiesel transport. Like the stages covering the transportation of soybeans, we can see that the transport of soy oil and biodiesel show a similar story. However, here the model assumes more complex combinations of modes and distances. Obviously, these won't represent every scenario, but one assumption I did find rather striking was that our friends at Argonne assume 46% of the biodiesel is moved by pipeline. Given the restrictions placed on us by our other friends in the petroleum industry, I think that assumption is tenuous at best. And finally, we can see the summary of emissions from soy crush to fuel tank. As discussed in the previous slides, there are three dominant sources of emissions that the industry will have to contend with: thermal energy, electricity, and methanol. As stated previously, we have a lot more technology and policy solutions for thermal and electric. Methanol will likely remain the most difficult source of emissions to remove. As a reminder, here's where we started and here's where it ends. 21.05, going from farming all the way through biodiesel transportation and distribution. I hope that this presentation gave you a better picture of the direct emissions associated with soybean oil biodiesel production and a better understanding of where those emissions or the hot spots are in the supply chain, specifically nitrogen decomposition, natural gas usage, and methanol. I hope that you walk away with the perspective that soybean oil biodiesel, while not net zero today, has a clear path as the wider economy decarbonizes. Thank you.
Thank you, Matt, for this interesting presentation. But as you already realized, this was recorded. Matt is on travel today, but I'm really happy that he did send us his presentation focusing on emissions on production and use of biodiesel. Thanks a lot. Next speaker is Thierry Yavid. Thierry works as a distribution network director at Bolloré Energy in France and Germany. He is the vice president of FF3C, the French Federation of Fuels and Heating, vice president of ECFD, the European Confederation of Fuel Distributors. He will tell us about the latest developments in the French market. Thierry, the floor is yours.
Merci, Moritz. I hope that everybody will understand my poor English. As Moritz has explained to you, I have the pleasure to join the organization this year. And it was very interesting to share the different experiences between all the different European countries on that way. First, yeah, you can go on the second slide. Okay, just to have a short presentation of the actual market in France. Heating oil is the third energy used after electricity and gas. You know that we are a nuclear electricity big producer. 50% of the energy in France comes from nuclear, and then we have so half of the houses are warmed by electricity. 11 millions are using natural gas, methane gas, coming from Russia, North Sea, and Algeria. And the third energy still used is heating oil. So heating oil is mostly used in individual houses. So on the countryside, not in the suburb of the big cities. Now we have to drive to go to our customers. We still have some buildings using heating oil, but it's decreasing roughly, and it's still providing heat to 10 millions of French people on 70 millions. So you can imagine it's still something important. So we go on the next slide. In France, yes, we are as the others. We support the consequences of the COP21, which takes place in Paris in 2015, and everybody has decided at this moment to make efforts to reduce the CO2 emissions everywhere. So in November 2018, the French government of Mr. Macron announced that he wants to see disappear the heating oil systems in 10 years. So in 2028. So all the profession has tried to find solutions. We have soon work on this some solutions, and one of my colleagues in south of France will get very good relationships with somebody world knows that I will show it to you. I hope you will recognize him, even if this information is mostly in French. I will try to translate the most important sequences of this set. Can I go on the? Yes, it's not my hand. You have to click on the HTTPS France free. If it's possible to show, can we have this link or not? Does somebody in the techniques can help me? Because when I try to connect, it doesn't run. Click. Wonderful. Control and go. It doesn't run. Yes, I agree. Tout accepté, yes. Go down. Go down, and here you come on the upstairs. Yes, and so click on the arrow. Okay, and just so, sorry, maybe you recognize this man. It's the Prince Albert from Monaco. In Monaco, you know, it's the place where if you don't want to pay taxes, you have to live. It's managed by the prince, and we have a good connection because everybody is a bit French in Monaco. So in Monaco, they have get the opportunity to use 100% biofuels, bio heating oils in the castle of the prince, and it has allowed to reduce the CO2 emissions up to 60 grams per CO2. Per kilo of kilowatt, and so that's a very good news. And the Prince Albert, which was very engaged in the process of the COP21, has made a choice not to produce warm city warming with the water of the sea, but to replace the connection with heating oils and natural gas by this 100% rapeseed oil. So sorry for the sound, but it's a very good experiences. So now 15 boilers in Monaco are using that, and we have the change that in Monaco the taxes are very low, and so they don't pay the real price we have to pay for rapeseed oils in the other places of France. In June last year, we have organized in France a climate conference with individuals, and the decision was taken to replace all the boilers in the global renovation programs by 2028. So it came back to the second point. And in 1 month after, the government has announced to limit the CO2 emissions up to 250 grams for new boilers, which will be sold at the 1st of January of next year. On the line downstairs, I have shown you what's the limit. So you see natural gas, it's 227. And so in France, we have tried to make an experimentation with the FF3C. And if you can go to next slide. Thank you. And we have signed an agreement between different organizations. So the first is the FF3C, of course. We are representing 3/4 of all the companies involved in heating oil distributions. The FOP, it's the French oil producer. So in France, unfortunately, we are not able to produce soy seeds. The climate is not warm enough, but we are able to produce rapeseed, colza in French. And so the producer are represented in this association, the FOP. The FFPI, it's the French petrols importers. We have also joined to our project the heating device producer and some of the heating installers, to show them that there is still a future for liquids energy adapt to the locations of our customers, the 3 million houses we have still to warm. And the first step we are running on now, it's the biofuel. Biofuel, it's heating oil in French. The F30, so it represents 30% incorporated in the oil. And so we are running these experiments through laboratories, official laboratories, and it's running from the beginning of this year. We got about 15 boilers experimenting these new solutions, and for instance, the effects are good, and we do that with the agreement of the official laboratory of oil. So in the ID to be agreed by the French laws, we need an official documentations to be accepted as soon as possible as a new energy. And we try to have an agreement of the public organism to reduce also the energy tax, which is mainly high in France in all energies, and we want to go to zero for the 30% of the bio we can include at this first step in the future heating oils we would be allowed to propose to our customers. Some of companies in France have begun to make sales of 5% bio in 95% of fossil heating oil. Okay, it's first communication, but it's also used by the green parties to say we are trying to make greenwashing. And in fact, we are still selling really fossil oils. So all our difficulties is now to convince the public powers to let us go in the 30% biofuel, and we are still processing studies up to 50%. And many of the members of the FEF3C are very enthusiastic on this point, and they accept, how do you say? They hopes that we will have the agreement for the end of this year to 2021 to be ready to commercialize these new products next year. And on my conclusion, it's the last slide. If you can change the slide. Yeah, thank you. We have created marketing accessories to communicate through our deputies, through the senators, through the customers, through the installers, and so on. With the FF3C, we have created a professional label, so it's biofuel energy of territories, in the contrary of energy of cities, with the flowers of wraps. And our pitch is we are not obliged to change everything if we want to change the world. So that's mainly sent to the green peoples, thinking that everything's liquids is bad and just electricity is a proud energy. So I hope I can come back next year to show you the good result of the first of this product.
Thank you,
Moritz.
Thierry. Interesting news, and I think it's really interesting that you do a lot on introducing renewable fuels into the market. I know there's lots of pressure, but you have this solution. That's good to know. Thank you very much for your presentation.
Thank you.
In the next session, we are dealing with market use of high biodiesel blends. And now we have a panel, and I would like to welcome the moderator, Tom Butcher. Tom Butcher is the technical director of NORA, the National Oilheat Research Alliance, and his group is providing technical support in the development of high-efficient renewable fuels. Thomas, the moderator of the following panel, and he will introduce the guest by himself. Tom, the floor is yours.
Great, Moritz, thank you so much. In this session, we're going to discuss where the U.S. is with biodiesel or FAME end use. As other speakers have said, the U.S. industry has made a commitment to specific greenhouse gas reduction goals, leading to full elimination by 2050. While other fuels may play a role in the later half of this period, it's biodiesel that is driving the transition now and will be for the foreseeable future. The industry has been working on biodiesel for quite a long time. The first report I have on biodiesel testing and heating systems was a study done by the R.W. Beckett Company in 1993. However, activity really ramped up after 2000 with several important lab combustion studies. Now there's a great deal of published literature on the use of biodiesel or FAME in boilers and furnaces worldwide. Early on, there were also some early important pioneering field studies. This includes studies of B20 done at the Warwick School Department in Rhode Island, a 100-home B20 study done in the Catskill region of New York, and a B100 field study done by the U.S. National Park Service. Beyond combustion studies, there has been considerable research work done over this time on fuel stability, coal flow properties, elastomer compatibility, and component durability. Increasingly, fuel marketers are using biodiesel blends. It seems that biodiesel levels of B5 are everywhere. The number of homes currently using B20 can be estimated in hundreds of thousands, and this is changing rapidly. There are others exploring or using higher blends still. This widespread field use represents an important base of experience that we should be and are looking at to help understand the practical long-term implications of biodiesel use. For this reason, NORA at several times has done surveys of fuel marketers and service managers to identify specific areas of concern. These survey results can then be compared to similar surveys done well before widespread biodiesel fuel use. These survey results provide good encouragement about biodiesel use. Things have been positive. Generally, problem areas such as nozzle and filter blockages are similar to those reported in earlier surveys. For much of this history, lab work, and the results of use surveys, There's a great deal of information available on the NORA website, and I don't plan to discuss this in any depth today. What we do have ready are pre-recorded videos from 3 leading fuel marketers. And these fuel marketers sell fuel, they install equipment, and they provide service here in North America. These are leaders who have been out front with this transition, using biodiesel at moderate and high blend levels. And so the idea is that you can hear from them directly. When we're done with this, we'll have a Q&A session if there are any questions, and one of the speakers, Charlie Uglietto, will be available live to answer questions. So we're going to start with a presentation by Levi Bourne of Bourne's Energy in upstate New York, really on the Canadian border, so quite cold area. So can you roll that video?
I'm Levi Bourne with Bourne's Energy. We are a third generation fuel dealer in northern Vermont, originally established in Morrisville by my grandfather in 1947, selling kerosene and fuel oils out of a gas station. And we've since evolved to several locations selling a variety of fuels from propane, fuel oil, kerosenes, as well as renewables such as bioheating fuel, biodiesel, and bulk wood pellets. We originally built our bio blending facility in 2010, I believe, bringing in B100, typically trying to purchase recycled cooking oils, and generally successful in doing so. Occasionally, we've had to blend in some soy-based fuels. And again, we blend ourselves at our plant. We have a heated storage, 10,000 gallon storage tank for the B100, and blend it in with whatever product we may be delivering that day. Since 2010, we've been selling a blend to all of our roughly 3,500 to 4,000 fuel oil customers and a handful of diesel customers. That blend may be a B5 up to a B20. We vary the blend. It's mandatory bio, but we vary the blend based on outdoor temperatures. In northern Vermont, it's not uncommon to see temperatures as low as negative 20 degrees Fahrenheit or colder. Which brings some transportation and delivery challenges. Generally speaking, as long as we stay on top of the blend, it hasn't been a problem for us. Just in the last year and a half, we began offering what we've branded as B99, but B100 to our general customer base. That is optional. We require them to sign a waiver acknowledging that their warranties on their equipment may be void. Which has not been a major issue, considering most of the equipment that we're seeing out there is several years old when people are making the transition anyways. So most warranties are void on pumps and that sort of thing. But that's been going very well. I don't know if we probably are somewhere in the range of 40 to 50 elected B99 customers. Very few issues. Generally speaking, I wouldn't say we have had any more issues with those accounts than we have with other fuels. I've been burning B99 in my house for roughly 5 years. I was kind of the test case for our company, and I'm a typical service technician that I only really service my furnace when something breaks or when it goes out on reset. So with that said, I've probably serviced the burner, cleaned my furnace maybe twice in the last 5 years, and any issues I had were more to do with neglect than the quality of the fuel. We're really looking forward to seeing what the manufacturers can do to get behind biofuel and higher bio blends. We're excited to see some of the B20 certified equipment out there, and we've been playing around with that. Generally speaking, whatever burner or equipment manufacturer we've put higher bio blends through, we've had virtually no issues or very, very few issues. Nothing that some setting adjustments or maybe a pre or post purge control can't resolve. So yeah, we're really looking forward to the future, seeing what equipment manufacturers can do to get behind this. Hoping to see some more fuel producers and some more recycled product on the market here in the future. Thank you for your time.
Thanks so much for that. We really appreciate all of these guys making these videos. Next, we're going to go to Steve Clark, who is the owner of Genesee Fuel on the other side of the country out in Seattle.
My name is Steve Clark. I'm the third generation owner of Genesee Energy in Seattle, Washington, where we are a fuel supplier, primarily heating oil, since 1929. In 2002, in an effort to combat customer loss to natural gas, we decided to offer our customers a B10 blend of biodiesel in an opt-in basis. Now, back in 2002, natural gas was viewed as the clean energy of choice. But back then, carbon reduction was not part of the conversation. It was only later that carbon elimination became the thing. Mainly, natural gas was winning because it was lower in particulates, sulfur dioxide, NOx, and carbon. But biodiesel offered us a good solution. Our early experience with B10 proved well, also on an opt-in basis. Now, our strategy behind the opt-in was to allow us to look at high blends and also to limit our exposure. We were worried about furnace malfunction, which had been warned would happen if we switched to biodiesel. In our experience, furnace malfunction and problems with clogged fuel lines and filters were limited mostly to very old systems. Our experience was that the clogged filters and end cone problems were mostly the result of poor tank quality and the contents of old tanks. We have many B99 customers that have newer systems and have been running B99 for years, and our technicians will say that it runs just like any other fuel. In general, we make no changes or alterations to the burner when we sign up a customer for biodiesel. We do, however, at the time of a tune-up, we will increase the pump pressure to 140 psi, and we will also switch to a biodiesel-rated filter and fuel pump. Since 2008, we've been offering 3 blends, and currently we have 100 B99 customers, 200 B50 customers, and over 1,000 B25 customers, some of which have been burning biodiesel since the mid-2000s. Here in the Pacific Northwest, we have relatively mild winter temperatures, with the average low daily temperature in the wintertime of not being below 30 very many days. We also have roughly 75% of our heating oil tanks are underground. So as you can imagine, cold flow is not an issue. We believe today is the time to push bioheat. We've made it our company commitment to switch 100% of our customers to B100 by 2030. Yes, it's aggressive, and yes, we know there will be some hurdles to overcome, but we know the demand is there, and we know that biodiesel works in home heating. So with the help of furnace manufacturers, biodiesel producers, and favorable policy from municipalities and governments, we believe it is achievable.
Thanks, Steve. And we're going to move on to our final speaker, which is Charlie Uglietto from Covey Oil near Boston.
My name is Charlie Uglietto, and I am the owner of Covey Oil and Energy, located just outside Boston, Massachusetts. We service approximately 6,000 plus accounts. We provide fuel delivery, 24-hour emergency service, and HVAC equipment. We were introduced to biodiesel in approximately 2008 and began delivering a B5 blend to our customer base. So we started with a B5 blend and didn't notice any problems whatsoever, and then began to progress from there to B10, B20, B30, B40, and now we're delivering a B50 blend to all of our customers. Our customers don't have an option. It's what we deliver, and we deliver it to both commercial and residential accounts. Our experience with biodiesel has been terrific to date. I have been able to work with NORA in a B50 test for, we just completed our second winter, and we're going to run it through the end of December. In our test, we have a whole range of burners, And we have some outside tanks in addition to traditional indoor tanks. One of the things that we've done as we've increased our bioblends is to continually look for new equipment to facilitate higher bioblends. So we buy fuel pumps that are rated for B20 or B100. We buy flexible fuel lines that are rated for B100. We use an oil deaerator, again rated for B100. And we really look forward to burner manufacturers producing burners that will be UL listed and warranted for higher blends. We feel that this is the future of heating, liquid heating, is with a liquid renewable fuel like biodiesel. Our experience with blend levels below B50 were really non-issues. We work with an additive company that had educated us about the fact that even B20 in an outdoor tank might be a problem, and we began using a cold flow additive for those outdoor tanks that has worked remarkably well. I can tell you that at B50, we've had some issues. Smaller nozzle sizes, the 0.50s, 0.60s, 0.65s are certainly a little more challenging as far as flame stability, lighting off, retaining the flame on the head. And it's not every burner, just certain burners, certain pieces of equipment. And we've resolved those issues through higher fuel pump pressures. Instead of the normal 100 or 150 psi, we have burners running at 170 and 180, and that has helped solve the problems about flame retention and making sure that the equipment is running well. Through the work with Tom Butcher and his team at NORA, we've begun to understand the importance of fuel stability, particularly if we're making a delivery in, say, May, and we're not getting back out there to top off the tank until October, November. So again, we turn to additives as very important. Filtration, we feel, is very important. We use spin-on filters. It's interesting for us in Greater Boston because we have fuel storage tanks that are out in the field that have been out there for 50 years, 60 years. We've got 5,000-gallon tanks. We've got 1,000-gallon tanks, standard 275-gallon tanks, but we have a lot of old tanks. We're not necessarily having a problem because the tanks are old. I think the switch to ultra-low sulfur fuel started to clean up these tanks, and then adding the biodiesel has certainly helped clean them up, and then the additive has further cleaned up those tanks. But we do find that we're replacing a lot more tanks than we used to, but not replacing newer tanks, not tanks that are 20 years old or 15 years old. All the tanks we're replacing are 30, 35, 40, 50 years old. So no real issues that we've had with fuel storage. Additives have been important for us to keep the fuel flowing, particularly with outside tanks and particularly with our B50 fuel. We have ratcheted up that cold flow additive, again, in conjunction with our additive company, that has solved those problems. As a company, we started to advertise the fact that we were moving to a greener fuel, bioheat at the time, as a way to differentiate ourselves from some of our competitors. Over the years, we have found that we are recognized for the biofuel levels that we sell. We advertise on all our literature, our website, emails, social media, that we are selling now what's been branded by NBB, the National Biodiesel Board, as BioHeat Super Plus. At the B50 level, that qualifies. And the response from our customers has been very good. This has helped them to justify their choice of sticking with a liquid fuel for the heating We get a lot of phone calls, a lot of thank yous that we have taken this on and made the choice for our customers. This past year in September, we started B100, so I burn B100 in my home, and I've got a couple of customers that burn B100 as well. I now have a number of customers that will be joining the B100 pool in June. I can honestly tell you that this transition to biodiesel, I think, has been an extraordinary lifeline for our business, our employees, our service techs. It's been a terrific experience for us. I look forward to moving the biodiesel blend level up to B100 at some point in time. I certainly look forward to our industry as a whole transitioning to liquid renewable fuels and very bright future. Thank you for your time. I appreciate it.
So I'm going to start off with addressing some questions that came in into the chat about the long-term stability. You know, a little bit of difference between North America and Europe. We get 3-4 deliveries a year, so there's a little bit more, quick turnover. I think in Europe it's more common to have one delivery a year, or maybe one delivery every 2 years. So the only thing we're really worried about is summer, the 4 months or so, let's say, over the summer. The nominal storage stability of biodiesel as listed in ASTM, there's just a side comment, maybe not even well thought out on the 6-month time frame. Increasingly, the research is indicating that, it's valid to increase that to maybe 12 months. There's a lot of ongoing work now on the stability of biodiesel blends, and the impact of adding fresh fuel, which may have stability additives in it, on the fuel that was left behind in the tank. So I guess that's a long way of saying it's a work in progress. Let's see, we're lucky to have Charlie on the line here. And if there are other questions for Charlie, this should be a good time. I don't know, Charlie, if you have anything else you want to add.
I would say, Tom, working with NORA and bringing up the issue of fuel stability, it hasn't been an issue with us as we've moved up. I mean, I think from yacht testing, you see some numbers that might concern you a little bit or show some fuel degradation, but from an operability standpoint, there has been no operability issues with the fuel sitting in the tanks for, minimum of 6 months on the heat only accounts that we've had. So I don't view it as an issue, and we're going to try to address that through additives, as you know, currently.
Thanks, Charlie. I do feel that, as we make this transition and as we go forward, this kind of field experience is incredibly valuable for us. But at the same time, I think that there's value in looking closely at least some sites to understand on a deeper level what's happening with the fuel in the tanks beyond just basic operability. So I think those two pathways in parallel are really going to be kind of a good way to get us to where we want to be.
Absolutely.
Okay, there's lots of chat, lots of discussion, but I'm not seeing any specific questions that we should be addressing. Long-term storage is one. Like I said, there's other research that's ongoing besides ours on the question of long-term storage, re-additizing, and so I think, there's a lot happening in this space, and I think we're gonna see even more coming out on it. Okay, if there's no further questions, I guess we're off the hook. Dave Sousa asks about cloud point levels. Charlie, do you want to say some things about the cloud point of the fuels that you're using and source maybe?
Yeah, absolutely. Our used cooking oil biodiesel, we get a COA on it pretty regularly from our suppliers. And so we're looking at something 33, 34, 36 degrees. Our soy-based biodiesel is higher with a cloud point. But again, we manage that through additives. at our B50 blend, our current additive reduces the pour point to minus 38 Fahrenheit. So our outside tanks at B50 experience no problems as long as we're using the additive. As we move up to a B100, I don't think currently there's an additive that's available to us to work on that. So, but from discussions with our additive company, they're looking at that right now. But again, it's a little bit different than heating oil in the sense that you have to know which feedstock is going into the biodiesel. But just as we did for heating oil, we had to go to a cold flow for outside tanks in very cold weather. So it's, same business, just you have to be a little more cognizant of what you're doing and how to prevent problems.
I see an important question that has come in on, and we get this a lot. Is there likely to be enough feedstock to meet the demands of the heating market? It's a question that we discuss a lot, and we look to the National Biodiesel Board, which has put forward projections on increased production of biodiesel in the future, which is very encouraging for us from different sources. Of course, we'll have to see. We are a little concerned that we will be competing with the transportation sector for the same fuel. But at least for the foreseeable future, the near future, it looks like there is certainly adequate capacity to help us meet the goals that we have set forward. And projections are that there will be biodiesel when we're ready for it.
To that point, Tom, I was with Donnell Rehagen from the National Biodiesel Board, and that point came up yesterday. And they have plenty of soybeans. They were saying that it's the crushing facilities that need to ramp up, but they're expecting their industry to have plenty of product for us as we increase bio levels across the entire Northeast Mid-Atlantic states. So they're confident.
Great. Charlie, thank you. So let's see, I see there's a comment from John Huber. I think all can see it. Okay, in the interest of time, Moritz, we should turn it back to you then.
Thanks, Tom.
Charlie, thank you so much for doing this.
You're very welcome. Thank you.
Thank you for this interesting insights to biodiesel issues. And it's really good to know that the product is now available and not only out of the lab, that you have it in the market. Interesting to hear. Biodiesel is a suitable possibility. And now we would like to switch over to other products. And we are thinking about a reality check. What is possible in future? What will be available? And we will have a look at the hydro-treated products at the end. And I would like to say hello to Klaus Luca. Klaus is the managing partner of Tech for Fuels. Tech for Fuels is a competence center for conventional and alternative fuels and lubricants and their application and use. Tech for Fuels is located in Aachen in Germany. Klaus, the floor is yours. I just heard that Klaus is not here right now. Maybe he has some trouble to connect. Maybe switch over to his panel then. Is Peter or Alexander in the line?
Hello, Moritz. I'm here.
Hello, Oleg. Sorry, we have to change a little bit because Klaus is missing for sure. He has some trouble to join. So we have to switch over. So, Oleg, we know each other so well. We are working together. You are working at Mabernaft here in Hamburg, and I know that you are dealing a lot with renewable products and thinking about how you can offer them. Oh, Klaus, so
Yeah,
nice.
hello, Moritz. Sorry
So
for
nice.
causing some trouble. I was in, I could see me all the time, but you could not see me. Sorry for that one. And yeah, maybe we can show the first slide, and I give a brief introduction into the talks of Peter and Alexander later on.
Perfect.
And I think, thank you for the introduction. And yeah, you said it, we like to have a reality check, what is there on the table for renewable fuels, and maybe you can show the next slide. So sorry for having some names in German, but don't care even about the right-hand side. It's saying it's gasoline, and we are now concentrating on the right-hand side, which is saying diesel-like fuels. What I'm going to present to you is what can be the future of renewable fuels, which is not like being fossil. So at the end of the day, we have to keep in mind that we have seen already the biodiesel or the fatty acid methyl ester. This is what the previous speakers have done. What I like to concentrate now is these lower three bubbles here saying gas to liquid, or I call it Fischer-Tropsch e-fuel maybe. The hydrogenated vegetable oil, so this is what Peter Sonnefeld is going to present, which is, let's say, state of the art, and let's say has some issues I will point out later. And Oleg will talk about, let's say, maybe some ideas on higher alcohols and idea here of a Fischer-Tropsch product derived from e-fuels. We are not talking about, let's say, dimethyl ethers or oxymethyl ethers, which can be derived from methanol. What I like to present to you is that there are already norms and standards in, let's say, in progress that like to go ahead, and the other ones are already in place. And to give you some points is the time frame. So HVO is there. E-fuels, I think Oleg will give a time frame, but I think from 3 to 5 years onwards, it can be there in large quantities. What is a framework which we have to consider is what we call the Renewable Energy Directive or the Fuel Quality Directive. And this is giving us a limit saying that the greenhouse gas reduction potential has to be above 70%, which means that if we do a life cycle analysis, some of the renewable fuels are even, let's say, start to have a hassle. And to underline those challenges we encounter, you might have heard that in Germany 2 weeks ago, our federal constitutional court had said, please, politicians, stay to your laws that you have made. And that means the goals that you have set are not high enough. So improve quickly. And I think yesterday we got the message from a court in Den Haag that Shell shall be responsible for his greenhouse gas reduction potentials. And we see that, at least here in Europe, we are under real strong pressure. So now I like to hand over to Peter Sonnefeld. Peter is presenting, let's say, one of the solutions which are already there. And later on, we will have the talk from Oleg. Thanks, Peter.
Thank you very much, Klaus. Don, if you could pull up the slides that I shared previously, that'd be great. What I'll do, indeed, I'll talk about renewable diesel, or HVO, the hydrotreated product. Our focus is very much on road transport at the moment. But I'll try to relate it to also some of the issues that I heard in the excellent conversation with Tom and Charles So I'll try to relate it also to where we see the applicability to heating fuels. Next slide, please, Don. So first of all, just a really brief comment on Neste. Who are we? We are by origin a Finnish national oil company founded in the 40s. And about 15 years ago, we came with the next BTL patented technology to make hydrotreated vegetable oil. And 15 years later, 90%, more than 90% of our profitability is really in renewables. And we focus mainly on renewable road transportation. But this product, renewable diesel, has applicability to heating oil. Then we have renewable aviation and renewable polymers and chemicals. Next slide, please. So what is renewable diesel? So it's a biofuel that can generate greenhouse gas emissions up to 90% in its pure form. Can be used in any diesel engine or existing infrastructure, pipelines, equipment, and it also has 10 to 30% local emission reductions dependent on the particulates. Next slide, please. This is a picture of the product. You can see on the right, you'll see diesel burning. On the left, HVO, or renewable diesel. Very clean burn. It smells like water. It looks like water, the product. Very clean burn. So we believe it's a really good product for what we like to do here. Next slide, please. A little bit of comparison between biodiesel, renewable diesel, and fossil diesel. So biodiesel, as most of you will probably know, is an ester. You can see here the formula. Renewable diesel is a synthetically produced diesel molecule, but it doesn't have the aromatics, which typically is the bad stuff. What would create cancer or gives the smoke, etc. The advantages of it are that it doesn't have any oxygen content, which is what really attracts the water. If you look at the biodiesel, there's quite a bit of oxygen in it, which creates water attraction. Cetane number, very high, better combustion, more power in diesel engines, and it has no aromatics content. It also has, I heard the conversation before about cold properties. So typically we sell it at -20 to -30 degrees Celsius, cloud point and CFPP, which would be, made a quick calculation, about -20 Fahrenheit for the -30 version. And that's in its pure form. Next slide, please. These are the markets that we typically sell our product in. So bus companies, truck fleets, construction, and so on. Heating oil, we actually sell it. We don't sell it that much yet, but maybe next slide, please, Don. We are getting more and more requests. So, and I very much welcome this conference. We're seeing more and more people starting to get interested in also reducing carbon in the heating oil industry. We've done some tests already in Germany and Belgium. You will have heard earlier on today by Arto Hannula in Finland, quite a lot of HVO heating oil sales. And we're also doing some tests in the UK. Typically, these have been blends, but we believe that HVO in its neat form will work equally well. However, we've seen that indeed with the burner flame, because the product is so transparent, that some adjustments need to be made to it for the burner flame to identify that there's actually a product in it, because the diesel, of course, or the heating oil typically is more yellowish. But it's a drop-in solution as well, can be used in any blend, and also storage properties are excellent, cold properties are excellent. So we believe it's a very, very good product for heating oil. Next slide, please, Don. Now, one of the problems, of course, is that it's more expensive. It's a better product, but it's also more expensive. And what we see is that on the road transport markets, because of the biomandates that exist, that it has a much more relevant and easier uptake. In the heating oil market, it's still quite expensive. What we see in Finland, though, is that at the moment, there's already a 3% biomandate for heating oil, and we see that going up to 10% in 2030. And we believe, and maybe next slide, Don, we believe that the way to really get people to use renewables is really by having biomandates, because ultimately, the product will cost more. People are reluctant to spend that money on their heating oil. Through biomandates in the renewables here, you can see that in the Nordics, for example, there's currently on average about a 20% biomandate obligation for road transport fuels, going up to 40 to 60% in 2030. The rest of Europe, we're looking at the moment at 10%, going to around 30% in 2030. And North America is also, developing some good biomandates. So we think that this model could actually work very well for heating oil as well. And then the final slide, Don, and then I'll hand over back to Klaus. So I heard also some questions on renewable, on the feedstocks and the raw materials. So we have over 10 different, maybe the previous one, thanks, Don. We have over 10 different feedstocks. More than 80%, actually at the moment, it's more than 90% is waste and residue. We're focusing all the time on newer feedstocks. And also, I heard the question, do we not have enough raw materials? We believe that over the next 30 years, even with a very significant ramp up of renewable diesel type products, so I'm not talking about the biofuels, but about biodiesel, but about the renewable diesel type product, we see that going from 5 million tons to 30 million tons in 10 years. And we have identified also already feedstock available to access to supply that product. So I think that's what I'd like to say at this point. Back to you.
Yeah, Peter, thank you very much. I think we collect the questions right at the end of the session, and maybe we give the floor then to Alexander. And Alexander will, let's say, give us the views of Maranaft on their vision of renewable fuels. Alexander, the floor is yours.
Thank you, Klaus. Yes. Hello, everyone. I think it kind of ties into what has been just said. Of course, Maranaft, maybe just a short introduction to us. We are independent energy supplier with over 13 billion euros of revenues and 18 million tons of fuels sold in different markets, mostly in Northern Europe, but also we have a presence in US and Singapore, and we have a large presence in UK as well. Apart from our key market, Germany, where of course we see a lot of legislation changes, even sometimes stricter than in the entire European Union, towards decarbonization of our key markets, which are road transportation fuels and heating fuels. So of course this topic is very crucial to us as well, and we are looking at different alternatives. I also believe that waste to fuels is a very interesting path, and of course Neste is working on this very actively. And for us as an independent supplier, in the end, we have this advantage of not being somehow tied to oil-based fuels. We can offer our customers innovative solutions. Thus, we are also looking a bit more mid-term and long-term, what are the alternatives, and our focus is very much shifting now to synthetic fuels, where I think we really have some interesting chances for different industries. Of course, you need to see it in a larger context. I totally agree that we will need some mandates and some other kinds of support to kind of ramp up these innovative fuels and to bring them into the market. But at the same time, I think the key markets for these fuels will be road transportation and particularly aviation, where you don't have a lot of alternatives really. And because we need to develop them for those markets, I think the heating market can also profit from this development. So basically, as Marbanaft, we are now involved in a number of corresponding projects. Some of them are in the area of sustainable aviation fuels, where we're looking into some projects in the area of alcohol to jet. And now our understanding is evolving. Basically, we will be an off-taker from these kind of projects and bringing these products into the market. But we see, for instance, in alcohol to jet products that projects that diesel is also a kind of sub product in these kind of projects. And of course, this is then an advanced biodiesel which can be used in road transportation and or heating. So I think the focus can be very much on increasing the share of biofuels and particularly advanced biofuels in this market. And our second and even larger focus is indeed on synthetic fuels, where we see a lot of potential to produce them, particularly in the regions with very cheap renewable energy, like Latin America, Middle East, and some parts of Europe as well in the south. I think there we're looking at synthetic fuels, and of course, you have different methods to produce them from methanization. There you get through methanol route to gasoline, which is of course less of interest for heating oil market, but there is also a well-known Fischer-Tropsch production process, which delivers, among other products, kind of paraffinic kind of diesel, which of course can be used in road transportation, but also as a component for heating to decrease the CO2 balance of heating fuels. And jointly with Moritz and his team, we are looking into this as well. To kind of promote these fuels and bring them to the market, we have established a joint venture with H&R, another Hamburg-based company, Hans & Rosenthal. The joint venture is called P2X Europe, and it's focusing on sourcing of these fuels and marketing them, particularly in Germany, but also in other markets. I can say that also as a part of this cooperation, there will be a pilot plant developed in Hamburg. We expect the production to start already this year, a very small plant, of course, but the goal is to, first of all, demonstrate this, that production of synthetic fuels is possible, that you can get grades and qualities suitable for normal cars and also for heating, of course, and on the other hand to push the politics a little bit to move on with implementation of corresponding legislation where we need a lot of clarity, taxation issues, quality directives, and so I just want to conclude with this, that of course we do everything we can from the industrial and commercial point of view, but we do need a lot more clarity and support from governments to bring this into the market. Clarity on how these products will be treated, how they will be accounted towards the greenhouse gas obligations. That being said, they are saving most of them over 90% of CO2 emissions. And finally, we also need some kind of support in this initial ramp-up phase. It can be in form of subsidies, or it can be in form of double counting, for instance, towards the greenhouse gas obligations, which is kind of being planned currently in the German legislation, at least. So we do have a lot of hope, and that kind of solves the long-term problem of feedstock, because solar energy and wind energy is widely available. It's just the matter of transforming it into the suitable fuels, I think.
Yeah, thank you very much, Alexander. I think you both touched very much the issue of, let's say, that support has to be taken into account in which direction anyway. So commercially viable, it is not if you need to compete with fossil components. This is what I understood from you both. What is the most favorable option? Maybe Peter, you start, and then Alexander. Peter, you have to unmute.
Yes, unmute. So unfortunately, it is indeed a more expensive product, and it's also, currently limited in supply. However, there's a lot of investment going on to increase capacity, which is based on the forecast of demand increasing. And so I think both of you and Oleg mentioned some of the German developments, which are becoming more ambitious. But as I mentioned in the slide before, what we see is that the key driver for uptake for renewable fuels and for decarbonization are the biomandates, and that is in Europe predominantly driven indeed by the RED, the Renewable Energy Directive, and the Fuel Quality Directives. So biomandates is the way, from our perspective, to grow renewables.
And Peter, maybe you can comment as well. I think there are some thoughts around to switch the energy taxation to a CO2 taxation. You would support this as well?
Yeah, it would really depend on how that, what that switch would look like. We don't think that at the moment, we actually don't see that the taxation, the CO2 tax, would really work to cover the gap between fossil fuels and renewable fuels. So we think it's better to focus on decarbonization, so that we say, look, these are the levels of decarbonization that we want to achieve. We want to create a level playing field, so for all technologies to have equal chance, really. So we don't just promote our renewable diesel or HVO. We think that all solutions are required. The challenge for to fight the climate change is huge, but we think therefore there needs to be a level playing field for all technologies, be it electric, hydrogen, e-fuels, P2X. There's so many different solutions, but we think that at the moment, from what we can see, that the Renewable Energy Directive and the biomandates that are within that are the best way to achieve it.
Thanks, Alexander.
I think I tend to agree that mandates is a very good kind of option to facilitate the development of these fuels, and technology openness has to be absolutely guaranteed. And of course, the consumer and the market needs then to decide what is the most efficient way to reduce emissions. And I absolutely believe that all available options will be required to achieve the indicated European and German goals. So we just cannot allow ourselves to limit our options to certain selected ones, like electric vehicles, for instance. And I believe that speaking of synthetic fuels, we will see a very steep cost decline in future, the same as we have seen with, let's say, solar energy. On one hand, we will see larger electrolyzers being built and cheaper ones. On the other hand, the cost of renewable energies will further decline. And of course, one limited factor for synthetic fuels is availability of CO2, which is also currently being solved through direct air capture. This technology is also quite expensive at this point, but from year to year getting cheaper and cheaper. So I believe that on one hand, mandates will help. On the other hand, the cost will decline as well, because we will see some substantial advancement of technology with the development of these fuels.
Alexander, maybe you can comment on the following one as well. We have here strong quarrels with the politics and our environmental agency, saying that, let's say, producing e-fuels does not make sense. It's loss of efficiency and all this discussion. I'm challenging you now, but I understood you see the plant in Hamburg as a demonstration and you are looking for different production places, correct?
Yes, absolutely. So the plant in Hamburg, of course, is only a demo plant just to show the viability of this technology. I absolutely believe that it makes a lot of sense to produce these fuels in other regions where we have huge availability of renewable resources, which will be otherwise not used, right? Where you have some unpopulated areas with no local consumption. And you cannot compare really the production of these fuels in Germany with production, let's say, in Latin America, where you have very different number of operating hours due to availability of, let's say, solar energy. And then it increases efficiency dramatically. And then bringing this otherwise locked energy in the liquid form to the consumption areas like, for instance, Germany, makes a lot of sense to us.
Yeah, that's good. Peter, maybe one question to your side. Fortunately, you are not the only one producing nowadays HVO. I think you have been one of the pioneers, but let's say you were setting the pavement for others, correct?
Yeah, absolutely. And, to be honest, we don't see that as, well, it is a threat, I guess, but it's a health threat. So we think competition is good. We think it just validates the fact that the solution is a good one. We used to have 99% of the market. Now we have 50% of the market, or a bit over still. That will probably go down. But we see that there's a lot of companies, oil companies, and renewable companies in particular that are really getting into the renewable diesel or the HVO production. So we think it's, first of all, it kind of shows that it is a good solution and that it's worthwhile going after. The second thing, though, is that for us, of course, it challenges us to stay ahead of the curve. And so we were the first in coming up with the product. Now, how do we stay ahead of the curve? And the way we've been doing that is, always going to worse feedstocks, if you will, so worse quality feedstocks, which makes the greenhouse gas reduction level higher. So going more and more towards waste and residues, to going to dirtier waste and residues, which need pretreatment, to find new feedstocks, to find new technologies. We're going also into looking into e-fuels and PTX, etc. So we need to keep on continuing to look for the next frontier. So in short, yes, there's more competition coming along. We think it's good, and we need to try to make sure that we stay ahead of the curve.
Yeah. Peter, Oleg, thank you very much. And I think this is near the end of our session here, and I switch back to Moritz. Thank you both.
Thank you.
Thank you.
Thank you, all of you. This was interesting to hear because I think this was a short look into the future. And I think this is what we need to explain why liquid products will have a future. Now we will have a short break of 10 minutes. And after the break, we will have an interesting discussion with boiler manufacturers dealing with renewable products and component producers. So don't miss that. Have a cup of coffee and be back in 10 minutes, which is 16:50 in Germany. Or yes, thanks a lot. See you in 10 minutes.
Der Klimawandel ist eine globale Herausforderung. Um die Treibhausgasemissionen langfristig deutlich zu senken, hat die EU mit dem Green Deal eine Art Fahrplan in eine grünere Zukunft entwickelt. Ziel ist, die Emissionen bis zum Jahr 2050 zu stoppen, auch im Wärmesektor. In ölbeheizten Gebäuden kann der Energiebedarf mit guter Dämmung und modernen Ölbrennwertheizungen gesenkt werden. Mit der Einbindung von erneuerbaren Energien wie Solarenergie wird weiterer Brennstoff und damit auch CO2 eingespart. Den übrigen Brennstoffbedarf können zukünftig erneuerbare flüssige Energieträger abdecken. Diese Future Fuels werden dem heutigen Heizöl zunächst beigemischt. Bis zum Jahr 2050 soll der grüne Anteil schrittweise erhöht werden und schließlich das fossile Heizöl ganz ersetzen. Um den Einsatz der neuen Brennstoffe unter Alltagsbedingungen zu prüfen, haben der Europäische Heizölverband Eurofuel und der Europäische Verband der Heizgeräteindustrie EHI einen 2-jährigen Feldtest gestartet. In rund 120 Gebäuden in ganz Europa werden die neuen Fuels jetzt getestet. In Deutschland beteiligt sich das Institut für Wärme und Mobilität mit verschiedenen Häusern an dem Feldtest. Europaweit kommen 2 verschiedene Produkte zum Einsatz: veresterte Bioöle, auch Biodiesel oder Farme genannt, und hydrierte Produkte aus Abfall und Reststoffen. Bei der Auswahl der Brennstoffmischungen wurden die jeweiligen landesspezifischen Besonderheiten berücksichtigt. In England ist Kerosin die fossile Komponente, in Frankreich ist Biodiesel der erneuerbare Anteil und in Österreich wird ein reines hydriertes Produkt auf Reststoffbasis verwendet. In Deutschland haben 21 Hausbesitzer eine Mischung aus Heizöl, Biodiesel und einer hydrierten Reststoffkomponente bekommen. Allein durch den Wechsel zu diesem Brennstoffmix reduzieren die Haushalte ihre CO2-Emissionen um mindestens 25%. Schauen wir mal genauer hin. In Schleswig-Holstein liegt der Friedrich-Wilhelm-Lübke-Kog. Hier wohnt Hans-Detlef Feddersen auf einem abgelegenen Hof. Umwelt- und Klimaschutz sind ihm wichtig. Seine Ölheizung hat er 2018 modernisiert und betreibt sie nun mit der neuen, treibhausgasreduzierten Brennstoffmischung, die übrigens wie alle anderen im Feldtest eingesetzten Produkte den geltenden Nachhaltigkeitsanforderungen entspricht. Weiter geht es nach Hessen. Hier in Wolfhagen steht das Haus der Familie Rau-Wolf. Auch sie haben das klimafreundliche Heizöl im Tank. Seit der Modernisierung nutzen sie ein effizientes Ölbrennwertgerät, das mit einer Wärmepumpe kombiniert ist. Die Hybrid-Heizungssteuerung ist besonders innovativ. In der Gemeinde wird der lokal erzeugte Grünstrom genutzt und mit variablen Strompreisen an die Haushalte abgegeben. Steigt die Produktion von Wind- und Solarstrom, sinkt der Preis. Dank der intelligenten Hybridheizung wird der Grünstrom in solchen Zeiten dann auch zum Heizen genutzt. Im rheinland-pfälzischen Baumholder wohnt Anke Georgiadis im über 60 Jahre alten Haus ihrer Großeltern. Das Gebäude wurde modernisiert und eine effiziente Ölbrennwertheizung eingebaut. Mit dem Einsatz des grünen Brennstoffs sind die CO2-Emissionen jetzt insgesamt um fast 90% gesunken. So erfüllt das Haus von gestern bereits heute die Klimaziele von morgen. Das sind nur 3 Beispiele des Feldtests, aber auch alle anderen teilnehmenden Haushalte melden durchweg positive Ergebnisse. Alle Anlagen laufen gewohnt zuverlässig und sind der Beweis dafür, dass die Zukunft schon angefangen hat.
Let's draw a future-proof heating. Heating with liquid fuels is the preferred option for around 20 million households in the EU. These houses are often not connected to the gas grid and have a limited electricity network. In this case, the heating fuel provides a reliable and sustainable off-grid energy supply. Innovation and sustainability are the core features of our industry. That's why we want to develop heating solutions contributing to the EU's 2050 decarbonization ambitions. But how? Well, we have a clear and gradual approach based on 3 steps. First of all, improved building insulation and modern condensing boilers are much more energy efficient. Condensing boilers can have an efficiency of almost 98%. Secondly, they can be simply coupled to renewable energy sources such as solar panels. And thirdly, thanks to the industry's continued research and innovation efforts, some eco-friendly new low-carbon liquid fuels are already available in a few countries in the EU. But what are low-carbon liquid fuels? There are many of them. They can be obtained through FAME, fatty acid methyl ester, by processing used cooking oil, or from HVO, hydrotreated vegetable oil. They can also be synthetic products achieved through innovative technologies such as power to liquid, where green electricity is synthesized into a liquid hydrocarbon. Beyond providing a huge contribution to reduce emissions, another great benefit is that low-carbon liquid fuels can be used in modern condensing boilers without the need for alterations. While many of our low-carbon liquid fuels are already available in lower scales, it is necessary to scale up their production. So we ask EU and national lawmakers to facilitate investments in new low-carbon liquid fuels for heating, to adopt a technology-neutral approach to decarbonizing heating, to recognize the greenhouse gas reduction potential of low-carbon liquid fuels in the revamp of the EU regulatory framework for renewable energies. If you would like to know more about it, please find all information on our website, www.eurofuel.eu.
Welcome back. I very much hope that you had a nice coffee break. And now we are coming to the next session, which deals on the technology of the heating equipment. Now we have all as well a moderator, which is Guido. Guido is the technical advisor of Infomosut in Belgium, the Belgium Information Center. There are you, Guido. His focus is on sustainable and efficient heating, as well as on the combustion of fossil and renewable heating. Guido is a member of the Technical Commission of Eurofuel and deeply involved in all technical questions of our organization. Guido, the floor is yours.
Thank you, Moritz. Good afternoon, USA, and good morning, USA, and good afternoon, Europe. I have the honor to have with me 2 specialists. We're now going to talk much more about hardware, not so much about the software on the oil, but we're going to talk about the technology on boilers. And I have Mario Bouchard with me from the Oil Heat Manufacturers Association, and also later, for my later questions, Raphael Lang from Bosch Buderus. Welcome, gentlemen. Thank you. You are specialists in the machine, in the boilers, and therefore we were very happy to have you with us. My first question goes to Mario, because when we were discussing about our panel discussion that we were having, we were surprised. I was a little bit surprised, and I found out that the US and EU market oil boilers have similarities. We both use liquid products, of course, but the heating technology is not identical. Can you explain a little bit, Mario, how the US market and European market are different as far as heating equipment and home heating is concerned?
Well, thank you very much, Guido. Yes, in North America, the main difference in the equipment is more in the system, the distribution system of the heat. So in Europe, many homes or most homes use highly efficient distribution systems like panel radiators that can run on much lower water temperatures to supply the heat in buildings. Where in North America, we're still in an older state of technology, and people aren't changing their distribution system as rapidly as manufacturers would like. And this has the effect of not being able to install more efficient boilers in homes. So you can take a 95% boiler and install it in a inefficient distribution system, and you will not profit from the full benefits of condensing or more highly efficient systems. So in respect to that, we're still using boilers that are more in the 85 to 88% range of efficiency. But in regards to using those boilers with the new liquid fuels that are coming into play in North America, it doesn't change anything at all for the use of the fuels. Just it's not making the system as efficient as it could be for the homeowners.
Okay, so and you said to me there's a difference between a furnace and a boiler.
So on a furnace, it's much easier to go into condensing because the warm air, the air circulating to the furnace coming from the return side is much colder. And in a warm air application, every furnace will condensate, and notwithstanding the application it's in compared to a boiler. But I need to add, though, that manufacturers do have both condensing boilers and condensing furnaces that are ready to run on either fossil fuel or low carbon fuels every time someone is ready to go and modify their system.
Okay. And from what I heard also during the day today is that your association has already a long track record with low carbon fuel mixes in boilers. We are really at the beginning there. We are testing, we are experimenting more or less. For instance, you already have a B20 standard, and others may still be coming in the coming years. Can you tell more about the technological challenges that had to be overcome when start using low carbon fuels in the heating systems? What can we learn in Europe from your experience? Because from what I heard just an hour ago, you already have B100 also. So I was really surprised that so many people are also using that, for instance.
So really, my hat tips off to the industry in the U.S. and in Canada for being very resourceful and using a lot of creativity to make the low carbon fuels that are available, to make them work in the systems that are in the market currently. And of course, what's available to us now is more of the FAME type biodiesel. And for years, we've been working on getting a standard that includes B20. And our biggest challenge, believe it or not, is not necessarily in the mechanical technologies, but it's more in debating with standards to get them to certify the different low carbon fuels that we have available on the market. So yes, we have B20 certified now. The burner manufacturers are ready and certified and listed for B20. And we were talking about going to the next step, which for us was B50. But knowing how long it takes for the standards to collaborate and get things going, we're actually looking at just stepping it up to B100 because we do have a standard that exists for B100, and maybe we could put that standard into the listings of the burners and the heating equipment, and not have to create another in-between standard to B50. But that's all in discussions right now. There's nothing done or officially done. But yes, most definitely, we are already on our way to B50 and beyond.
So new boilers are, let's say, B20 ready when they are sold for the moment?
So the actual product itself, when you look at a heat exchanger being a warm air furnace heat exchanger or a boiler heat exchanger, the fuel that it burns, the flue gases that are circulating through the heat exchanger, whether it be full fossil fuels or low carbon fuels, the heat exchanger doesn't really see a difference as long as the burner can burn the fuel as it should and offer the proper BTUs as per the unit is certified and listed to, as far as the maximum allowed quantity of BTU going into the appliance and out of the appliance. As long as those are respected well, the appliance are giving us a very good positive feedback and reaction to all this. And there is no real issues with the appliances themselves. As long as the burner burns like it should, the appliances are really happy just to work with any fuel that you're giving them.
Did the manufacturers, more into detail about this? We are in Europe. We also think about maybe that manufacturers have to agree on, okay, my boiler is B20 ready. Does it exist some kind of label in US? It exists.
Yes, it does. You in North America, you have two certification bodies. You have CSA in Canada and UL in the US. CSA has already done a B20 certification code for the heating appliances up to B20, either be water heaters, furnaces, and boilers. And UL has a different sets of standards than CSA, but right now there's a collaboration between CSA and UL, so the same verbiage can be taken from one code to the other and make the codes happen faster, so the units can be listed faster.
And does for instance, because also sometimes people that have already a boiler for 10 years in their home want to change to that new product, do some kind of technical documentation or sheets exist for technicians? What they have to be aware, what things to watch, thinking about ducts, thinking about aspiration of the, does it technical documentation exist for technicians on that?
So right now the documentation is in progress. That's one thing that the Oil Manufacturers Association wants to work together and put in place. So we make sure that the technicians that are working on the equipment do have some guidelines that they can follow and some tips to let's call it convert from fossil to blended fuels. And so they can adjust these and make sure that they're working in proper conditions, so they meet the listing under which they're listed for.
Okay, great. So you help technicians to make the product run correctly in the boiler.
Absolutely, we have to. It's a collaborative effort, and it needs to happen.
Okay, thank you very much. I'm switching now to Europe a little bit. About we have different issues in Europe. I present to you Raphael Lang from the boiler manufacturer Bosch Buderus, which is one of the most important boiler manufacturers in Europe, and I think maybe also in the world. In Europe, we have another discussion going on. We have much more water-based systems, and we focus really on efficiency. Efficiency is key in heating. Condensing boilers are more or less, let's say, standard for new boilers. Every new boiler which is sold has to be at least condensing. What do you see is still coming, Raphael? How are heating systems on liquid fuels going to evolve in the coming years? Can we still see some improvement on efficiency? We 98%. I don't see how we can get over it.
Yeah, you're absolutely right. Thanks for the welcome, Guido.
condensing boilers are standard when you look into our production line. That's absolutely correct. They are not standard if you look into the basements of our customer. And therefore, it is absolutely important, let's say, focusing on Germany, the biggest oil boiler market here in Europe. There's still a strong need to increase this exchange, to have renovation, have a higher renovation rate, to get to these high efficient condensing boilers in these buildings we're talking about. So it's quite important. We're not talking new build. I think that is clear. There we have a lower heat demand, and heat pump is for sure very strong and with a good reason. But looking at these existing older buildings with higher heat demand, the liquid oil boiler is still a reasonable choice, and there is still room to improve. As we as a manufacturer, we have a lever here in our hand, let's say. We are focusing on attractive products which are easy to install and have an easy fit to the existing installation. And with that, we want to give the customer a future perspective. And that's why I think this green fuel readiness, how you like to call it, that's so important. So we allow today, as a brand, our products sold in Germany already a huge variety of green fuels, even today, to give the customer this this future proof or this future readiness. But your question, Guido, was quite interesting and had a detail and a partially answer in it as well. You were talking about a system. So I think it's important not to just focus on the appliance, but also talking about the system. And therefore, I want to highlight hybrids as an example. So a smart combination of a liquid fuel boiler with a heat pump, for example, or a solar system, whatever you want, can manage this balance between CO2 reduction, decreasing the amount of liquid fuel on the one hand, and meeting the heat demand of these existing buildings, like high flow temperatures, on the other hand. So with this perspective, the result is a reduction in the consumption of these green fuels. And I think then this is a real option, despite the restrictions we have today in the availability and limited production capacities. But I was happy to hear in the panel before that even this will change in the future, and there will be reasonable amounts and also prices available. So so sum it up: renovation, a hybrid, and then giving future perspective with green fuel readiness.
So it's more or less the Eurofuel three-step approach that you're also pledging to, that's the way that the sector has to go to in order to arrive to let's say the ambition of 2030 and 2050, if I'm correct.
We as Bosch absolutely 100% say yes to exactly these three steps.
And we need all the different energy sources, because not always electricity is the solution, not always natural gas can be used, and not always the oil can be used, depending on the situation. Definitely.
There are still installations where liquid fuel is the most reasonable one. So and there must be a solution.
Can you just explain a little technically how, the combination with the boiler and the heat pump, how is it working? Is the boiler the one of this backup, or how is it mostly used?
So I would answer with some results in actual tests we had before launching what we call the hybrid. So the logic, the hydraulic logic, as well as the electric logic, that is the key. And what we see in real installations, that heat pump is covering a lot, actually. And then, to use your terms, the boiler is really the backup then for these really cold days we had this winter, for example, in Germany as well, and to cover this quick and high demand.
Okay. And the next question is, oil heating customers also want to evolve to eco-friendly heating systems in their home. How can oil heating systems become low carbon ready? And what is needed around the boiler and the heating system to make it eco-friendly?
Mario explained already a bit the difference between the US and Europe, and therefore I would like to point out a bit different. I think it's not a good idea with the ambient conditions we have here, German market, let's say, it's not eco-friendly, I would say. I think that's an important message, to just fuel an old system with a CO2 reduced fuel. So these fuels are precious, and as all energy, they need to be handled reasonable and not wasted. And if we have these situations, which we have here in the European market, I think, again, this reduction or this increase in efficiency at first is important. But then, when you have that, and when you have hybrids, for example, and then mindful usage of your systems, or like energy monitoring, for example, but when you have all this in place, then we've seen it's a quite easy job. So talking about modern systems, so modern appliances, oil tank, as well as piping, a switch to a green fuel, that's not complicated. And our in-house tests, we've shown that especially paraffinic fuels can be used absolutely without any issues. So our mixing system is able to handle it. Flame detection, we heard that before, also not a problem in these cases. Besides the in-house tests, we also collect experience in the external. You mentioned the EHI field test already. We use a R33, 7% FAME and 26% HVO. We have this fuel running in the appliances without any issue. A CO2 reduction of about 20%, quite easy. Secondly, to mention maybe the initiative from IWO, the Future Fuels at Work. Another example where our customers can witness really how easy and problem-free the use of these CO2 reduced fuels really is.
You're also involved, maybe not yourself, but somebody of your company, or maybe yourself, in those European field tests. The first information that we get also from in the technical commission, that it's running without any problems. In Belgium, we had 2 tests already. I think the person from Neste mentioned it. We also experienced no problems at all. Did you? What your experiences? Flame detection, no problem. Filters, no problem. It's running smoothly, if I'm correct.
Yeah, I'm much more involved as you would think of, because I'm one of the customers by myself. So.
Okay. Okay.
So I have by myself such fuel. I'm part of the field test myself, but also deeply involved, of course, knowing the appliances and recording the measures. And yes, we don't have any issue so far. Absolutely correct. And this is talking about the ones we do in Germany. We also have some in Austria as well, in Switzerland. Yeah. And also there, no problem at all.
It's good news to hear that you're not every day sitting around your boiler to check it, because probably it's not needed. So it's running very well. Okay, thank you very much, gentlemen. Thank you very much for your feedback and the questions that were answered to our audience. I think this gives a good idea of how we are experimenting in Europe with those new fuels. And as we see in North America, you already have much more experience with it than we have. Thank you.
Thank you for having us. Good work on that conference.
Thank you.
Thank you, Guido. Thank you, Mario. Thank you, Raphael. This was really interesting to see that things are running well. Things are running well with today's renewable or partly renewable fuels. So we are coming to our last session. It's not only boilers, it's also components which are important for the proper use of renewable products. The moderator of the next session is Sandrine DeVos. Sandrine is the Secretary General of Eurofuel. I'm sure you may already know her. She has over 10 years experience in EU politic affairs, and she is the central point and the contact person and the face of Eurofuel in Brussels. Sandrine, the floor is yours.
Thank you, Moritz. Good morning or good afternoon to all of you. So, as Moritz said, after talking with the boiler manufacturers, I'm delighted to welcome you to this session focusing on the combustion equipment. And so, what can be done to make the next jumps in efficiency? And to reply to this question, we will have 4 speakers. First, 3 talking for the European side, and then 1 talking for the US side. So welcome to all of you, dear speakers, and thank you for joining us today. And we will first start with the European side. So in this panel, we have Francesco De Cimone from FIDA, which is an Italian manufacturer of ignition devices and part of the Beckett family of companies. Then we have Giuliano Conticini from Ariston Thermo Group, which is a global leader in thermic comfort and energy efficiency. And finally, we have Laurent Chevalier from Suntech, a manufacturing company of gear pumps in both France and the USA. So welcome to all of you, gentlemen.
Thank you.
So,
thank you.
My first question will be, what can your company do to contribute to the energy transition? And maybe I will ask first Giuliano to start on this question. So what is your company doing to contribute?
So in the last years, we worked a lot in terms of efficiency, preparing and growing in the preparation of double stage burners and modulated burners, knowing that modulation is very important for the efficiency. In addition, we worked a lot to improve the pollution, to improve the emissions in terms of NOx, in terms of CO, in terms of we are really convinced that it's very important for components manufacturers, boiler manufacturers to offer for the future with oil something that is not just working with biofuel, with the low carbon fuels, but also promising and assuring that we can reduce NOx emissions, we can reduce. This is very important because otherwise oil it's considered a very polluting fuel. So electricity isn't the mind of everybody, of all the governments. Oil can promise a lot. We can work. The technology is there. All the competitors, all the players in burners have very, very good technologies for reducing NOx. This is important. Let's imagine for replacement that we are allowed to replace the old burners with the same burners, 30 years old technology. We have to move to a new low pollution burners. This is very important. Just to think the tolerance is in the field, 20% is allowed. So all this environment, all around oil must be reduced. We have to invest. We have to continue to invest. We have to promise to the world, to the governments, much less pollution. In terms of low carbon fuels, we are testing. We are testing HVO, we are testing F30 received from FF3C from France, both in France and in Italy. We burned something like 30,000 liters of oil. We are very good conditions, and we can promise for the future very good combustion with the liquid fuel.
Thank you, Giuliano. Very good points indeed. Francesco, may I ask, how can transformers contribute as well? Francesco, you are mute.
Can you hear me now?
Yes, much better. Thank you.
Oh, thanks. Hello, everybody. Yes, the transformers. Okay, we produce transformers mainly in two topologies, and we have electronic transformers and inductive transformers. Obviously, we follow the request by the burner manufacturers. For this, we have a very good synergy, for example, with Mr. Conticini and Ariston, because we have made some improvement about the ignition inside the burners with biodiesel. And we see that that the ignition it's not an issue because we see that the ignition requested by these new burners is similar to the one requested by let's say the old burners. So we are flexible and we can follow the burners manufacturers, but first the choice is by the burner manufacturer, and then FIDA could have to find out the right type of ignition transformers.
Thank you, Francesco. Laurent, may I ask you the same question? What is the contribution of your company?
Yes, thank you. Sorry?
No, we're listening to you.
Yes, thank you. Thank you, Sandrine. We are a small player in this major change in the heating and oil and furnace industry. Suntech is, though we are a key manufacturer because we make a very important component, which is the pump, and we have been making and manufacturing pumps for several decades now. One first thing I would like to share with you is that we do take very seriously this major change in the market, and already 60% of our sales are made with pumps which can regulate the flow with a B20, and we are actively working on the B30, which is scheduled to be launched on the market in 2022. And next step in 2023 will be B100. And we have already some of our large pumps which are compatible with the B100. And to achieve that, although we are a small business and we make sales in the area of 30 million, this year we shall invest 10% of our sales to develop and to work on new products. So for us, the switch to biofuels or HVO is already a reality.
Right. Thank you, Laurent. So the reason why the three of you are in this panel is because, like many other companies as well, you are doing a lot to contribute to the energy transition, but we came to realize that you are actually all working together on this issue. You're just not working in silos. You are using the synergies between you. And I got very curious about that. Could you tell us a bit more how you came to this process and what you're doing together? Maybe Giuliano, you would like to start?
Sure, Sandrine. The burner is a component for the unit, for the boiler, but pumps, oil pumps, and transformers are components for me or for all my competitors. So it's very important when you face a new situation like a biofuel. Any fuel has different conditions. So bio is very important for pump, one of the most important components in the burner for compatibility of materials inside the pump, or just to say the stop and the start, the regulation of the oil. And on the other side, the ignition, as Francesco was mentioning, ignition, you have to give the minimum energy to the fuel, depending on the characteristics of the fuel to start, to be ignited in cold conditions or the sand. So to work together to obtain a minimum energy involved, compatibility of materials, good general condition for the system. Burner is a system, mini system is very important. So work together is essential in our work.
Right. Laurent, I assume you would say the same. Are you working as well with other companies worldwide on these questions?
We have to. In fact, every region, every area, as Giuliano said, is specific. We are organized in that direction. We are very much customer intimacy in our processes, and we have definitely to listen to our customers' requirement. And we first started years ago when we worked to improve the efficiency of our pumps in order to reduce the energy consumption. And then for years we have been working and triggered by our customers, whether OEMs or distributors, to adapt our pumps to these new type of liquid fuels, whether FAME or HVO. And there has been part of technical resources to be dedicated to that, to those new fuels, and also accept to be very pragmatic. We have invested in our laboratories and testing capacities because we know that it takes hours and hours of testing before we put and we deliver a pump to our customers, and specifically even more when we know that all customers, they have specific requirements. But we are organized, and we manage our operations to stick to those factors.
Thank you. Francisco, what are your views about the synergies between the different components, and do you have next steps in mind?
Actually, the range with our transformers, our range covered more or less all the requests about this new technology. What we are making is about new searching or about high voltage cables, because the ignition is not only the transformer. It's made by primary cable, the transformer, and very important, the high voltage cables. And in this product, we are making a lot of research in order to find out some alternative if needed, because till now the banner manufacturers are using the actual range we have about high voltage cables. By the way, we are flexible, and we are ready to follow the customer's request.
All right, thank you. Are you also all working together with low carbon fuel producers to help you in your tests, for example? Giuliano?
Sure. Yeah, sure. So in detail, we are working with the Suntech, both for two types of pumps. One is for single stage, and this is one interesting activity. And the second one, we're working on modulating. Modulating is a very difficult and very important activity for us, strategic for the efficiency, to reduce, to increase the efficiency of the system, and it's an important activity to test, to develop, to improve the system with low carbon fuel. So this is an activity very important.
Laurent, would you like to add anything? I see you nodding.
It's after Giuliano, I can only confirm and share the views. For example, being pragmatic, we have organized our supply chain to be always looking for new suppliers, new solutions that we can test in our laboratories to adapt to those new fuels. We have been working on the seals. It's a different viscosity. We had to adapt also to the change of temperature inside the pump, especially when it's close to the burner. But we are all the more happy to do that, to find solutions and to support our customers, OEMs and distributors, to improve their response to the market, because we believe that biofuels are a very economic solution for the end users, whether they are end users, houses having a domestic burner, or industrial users. For very economic cost, they can adapt their equipment to biofuels. And for us, it has become very important to bring that information to the market.
Thank you. I think it's a very positive message to see that all the stakeholders in the sector are working together on this. And I had myself the opportunity to visit some of your labs or test rooms, and that's very impressive. So I look forward to continuing your results in the future. I thank the three of you very much, and we will now turn to the USA with Tom Butcher, who has already been introduced, but he's the technical director of NORA. And Tom will tell us what is needed to achieve high efficiency in practice. Tom, the floor is yours.
Great, Sandrine. Thank you so much. I feel that some of the things that I'm going to say have already been said, and so in a way I'll just be reinforcing them. We've heard several comments about efficiency both last week and this week, and I hope to leave you with the idea that efficiency is really important, and we have room to improve, and it should be an important part of the equation for achieving lower greenhouse gas emissions. So there's a point made last week by Mr. Linke in his presentation about how significant the role of equipment replacements and efficiency improvements can be in this overall situation. And I was encouraged by that, and I clearly agree with that. So here in the US market, North American market, we have both heating boilers and warm air furnaces. Fair to say, I think the boilers are a bigger share of the market, but warm air furnaces are also really important. I'm going to emphasize maybe a little bit more on the boiler side. From our past research in this area, we realized that replacing old systems with new systems, particularly high efficiency systems, can achieve savings of 25% in the field, in that range. Pretty significant. And some of the government agencies are setting goals for energy reduction that are in that order. So just that can help achieve significant improvements. One type of system on the hydronic side that's pretty common in the US is a heating boiler that also provides domestic hot water through internal coils, tankless coil boilers as we call them. These need to stay hot in the summer to be able to meet the domestic hot water demand. So old style boilers, I think you could call them, they are still a significant part of what we have in the field. The other aspect of our hydronic heating systems that Mario had mentioned is that the distribution systems are based on higher temperatures, 170 degrees F, for the design condition. Now, advanced controls such as outdoor reset controls can be used to reduce those temperatures during the milder parts of the year and achieve better performance. This is great. These are required now on all new boilers, these types of controls, except boilers which have internal coils for domestic hot water heating. NORA has an active rebate program that provides direct support for the replacement of old heating systems with new systems. And this has a great impact on getting new equipment into the field. This type of a program can have the greatest impact when the new equipment is at the highest efficiency level. And I personally will continue to campaign for this direction. There's a discussion from our U.S. Department of Energy about the possibility of raising minimum efficiency standards to require only condensing equipment. Just a discussion at this point. It's doubtful, I think, that it'll really go somewhere. But the higher temperature of our thermal distribution systems, of our radiators, would seem to make this impossible, because the systems, while they do well on the tests, they won't really do well in the field, and so those savings won't be achieved. It would seem that the most practical way to achieve efficiency benefits with hydronic systems in North America is through, of course, steady state efficiency, going to high efficiency but not condensing, just falling short. And there are some systems that are doing that. Better insulation on the systems, focusing on low load losses, keeping the efficiency as high as possible when the load is very low. Separating domestic hot water from heating in different ways, from a control perspective, from a temperature perspective, and absolutely advanced control concepts, which, and there's a lot of creative ideas out there for doing that. Current federal test methods here in North America, US, are based on heating only and do not yet include domestic hot water, so combination systems. And so manufacturers don't always get rewarded in the proper way for some of the high efficiency measures that they could implement. I think that is an area where we need improvements. For the case of warm air furnaces, condensing might be easier technically, but it's not at all clear that the benefits are worth the cost here and service needs. You know, as we look at the economics of heat pump options, it becomes clear that a low efficiency existing system is a really great candidate for conversion to heat pumps. Getting better equipment out in the field, having the highest oil heat system efficiency possible, is a good way to kind of make the counter argument against heat pumps. So my overall point again here is that we should continue to focus on efficiency. It's really important. There are lots of opportunities to do things better and get better equipment out in the field, and it should be an integral part of the strategy of addressing greenhouse gas emissions. So, thank you, Sandrine, and I turn it back to you.
So it seems to be that Sandrine has some technical problems and left already. So I can say thank you to all of you. This was an interesting discussion regarding components and about how companies work together. I think that was great news. Thanks a lot. Now we are nearly at the end of today's conference. But before I hand over to John, I would like to thank you for joining today's conference. And I also would like to thank everyone who contributed to the success of this event, everyone on stage and behind the curtain. John, thank you again for the good and fruitful cooperation in preparing this event. And now I would like to hand over for your conclusion. Thanks a lot.
We've had 5 panels today with 15 speakers. Nearly 100 people have been participating by watching this today, and we appreciate all of those for what they've done. We have heard today from retail dealers on how they're incorporating biofuels and high efficiency equipment in their companies, to manufacturers of fuel about how they're going to make better fuels for the future, implementing new technologies, new feedstocks, all critical to liquid fuels being a big part of the future for Europe and North America. We've also heard from the manufacturers and how they are making equipment suitable for those new fuels, all critical. I think that, you know, in summing, the most important thing we're hearing today is how much effort is going in to from everybody throughout the world as to making equipment and making biofuels, e-fuels part of our future. Without this work going on in both continents, none of us would have a potential future. With this work, I think we will find over time that we will be the critical source for heating and transportation into the future. I think we all understand that electricity has substantial limits on what it can accomplish, where we have been able to power the world for many decades. And with the new liquid fuels that we're having, we'll certainly be able to accomplish the same things going into the future. I want to thank the moderators in particular for what they've done. The speakers have done an excellent job of preparing for this conference. I want to thank Moritz and Sandrine for ensuring the European side is very strong, which has been demonstrated here very much. Don Farrell in the background has kept this looking like a very professional presentation, and we want to thank him. He did much of the work last year also. And And the other thing I want to make sure is that we have a way of rating the conference. Beneath the screen, you can give a quick rating. We would welcome comments in the comment board as to what you would like improved on this conference, what you liked about this conference, new topics, whether and when it should be repeated, essentially anything, any thoughts that you might have on the future of this type of conference. We also have a rating button right underneath the screen where you can say whether it's, I can't see it on my screen, but presumably you can rate it from a point to a point, which would give us feedback. And obviously the more feedback we have and the better comments we have, the better able we are to deliver a better conference to you the next time we choose to do this. So thank you very much, and I will return it to you, Moritz, for a wrap up.
So thank you from my side. I think we are nearly at the end of today's session. We are relatively good in time, so thank you to all to have a look at the timing, and I think we've got interesting insights. And thank you again, and bye-bye. Hope to see you next time. Bye-bye.